So today we're looking at how we can find factors for our AC method just a little bit quicker. So we know we can use a full table where we try every single option until we find it, but if the factors are rather large, it could take us more time than it's maybe necessary. Now, I don't like to start off with this at the beginning just because I want us to have a basis in how we actually solve these and factor and know at least one technique that will guarantee to work. And this one's a little bit disjointed when we talk about all the different ideas. So some helpful factoring signs that we want to look for is we want to know how many terms does a polynomial end up having. So if we know if it has 2 terms, if it has 3 terms, if it has 4 terms, we have to approach each one of these differently. For instance, for 2, all we have is greatest common factor and their difference of squares. For 3, we're typically looking at the AC method, and remember that the greatest common factor is still something we want to look for. And then when there's 4, grouping is what we want to use. And again, we're still always looking for the greatest common factor. So the GCF should be looked for in any type of polynomial problem forever. That should be the first thing. Can I take anything out to make my life simpler? But when we focus in on the AC method, and we have our generic trinomial, our quadratic here. So here's our generic, or let's call it our standard form, because that is what it is. So we have our quadratic in standard form. There's a few things we can look for that help us figure out what type of factors we're looking for. So this symbol right here is going to tell us if we have to add or subtract our middle term. So we're going to add or subtract our middle term. While this symbol tells us which of the factors is larger. Is the positive the larger? Or is our negative larger? Oops. So for instance, if I had x squared plus 3x plus 2, this plus is telling me that my factors are going to add to the middle. So when I find my factors of 2, 1 and 2, I know that they have to add to become 3. Because it's a plus 3, I knew both of these were positive. If this was a minus, I still have to add, but my two numbers are going to have to be negatives in order to make that happen. While if I had x squared minus 2x minus 3, this minus sign right here tells me that I have to subtract my factors. So when I'm looking for two numbers that multiply to negative 3, the two numbers are going to subtract. And then, because it's negative, the negative number, or the larger, has to be negative. So I know it has to be these two. Just some ways that help us when the factors get larger. So I want to kind of practice these ideas and find all of the possible values that would work for letter K. So if I was going to factor this, what would K have to be to make this factorable? Because technically, the question I have over here, what are the possible values of K? Could be any number I want. It should be to be factorable. So all my questions don't have that on there, so I'm going to have to add those later. So what are all the possible values of K to be factorable? Well, AC method 1 times 18 So I need to find all the factors that are going to multiply to 18 but are going to add to k. So 1 and 18, basically I have to find all of my factors. 2 and 9, 3 and 6. So k could be 19, k could be 11, k could be 9. Those are all the different values. It can't be any other number because I need them to multiply to 18 and add to k and be positive. Same question. Again, I want it to be factorable because, again, all the possible values of k could be any number if I just wanted to plug a number in. So I need all the numbers that would multiply to negative 48 but combine to give me k. Since it's a negative, I know I'm going to have to subtract. So I'm going to go 1 and 48. We're going to go 2 and 24. We're going to go 3 and 16. We've got 4 and 12. 5 doesn't work, 6 and 8. And we know right here that the next one will be 8 and 6, and that would repeat. But there's a lot more values for this one. Since they have to subtract, one of these has to be negative, one of these has to be positive. So let's start by making all of these negative. So k could be negative 47, negative 22, negative 13, negative 8, and negative 2. But it also, well, actually, it can't be any of these numbers because I need k to be positive. So instead of having my negatives on this side, I actually need the negatives on this side because I need my larger number to be positive. So k won't be any of these. K will actually be 47, 22, 13, 8, or 2. All the positive versions of those numbers. So I knew I had to subtract, and I knew my answer had to be positive. All right. I'm going to add my two factors, but the result has to be negative, so both of my factors are going to end up being negative. So I need two numbers that multiply to 72 but will combine to be a negative. So again, negative 1, negative 72, negative 2, negative 36, negative 3, negative 24, negative 4, and 4 goes into 72 18 times, I think. Just going to double check to be sure. Fairly confident, yep. 18, 5 doesn't work, 6, and negative 12, negative 8, negative 9, and then right there it would switch and be negative 9, negative 8, and we would be repeating factors after this. So k is going to be negative 73, negative 38, negative 27, negative 22, negative 18, and negative 17. So these are all the values that k can be where they multiply but combine to give us a negative middle value. All depending on, and then which of these factors will we end up choosing. It all depends on which middle number. If this was a negative 73, these would have been the two factors we're looking for. I need a negative 60, but I need to combine to a negative number, so I know I'm going to subtract my two factors, and the larger number is going to have to be negative. So we're going to go through and just list our factors first. 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10, 7 doesn't work, 8 doesn't work, 9 doesn't work, and then we're back to 10. So here's our complete list of factors. They need to multiply to negative 60, and since the middle is negative, our larger number needs to be a negative number. So k on this one is allowed to be negative 59, negative 28, negative 17, negative 11, negative 7, and negative 4. So making a complete list can help you find any of the possible factors that could be in the middle for any of our problems. But it could take a while, especially in some of our cases where the factors could be like 18 times 15. It would take you 15 tries if we do it in order. So there's a few ways we can do it that go faster. Take this one, for example. 3 times negative 20 is negative 60. We just made a list for it on the last page, but we're going to kind of approach it differently. We know that if this thing is factorable, we're going to have two binomials. We're going to have the r's right here. We're going to have regular numbers here and here, and in each one of these blanks. Because it's negative, we know that one of these is minus and one of these is plus. What's cool is we can actually kind of guess and check what it could possibly be. Looking at 3, the only way to get this first term, if we think about FOIL, is you take this times that. Well, the only way to get 3 is to multiply 1 times 3. So we know that our binomials are at least like this. The 3 could be over here, the 1 could be over there. Then to get 20, there's a couple different options. I'm going to move my word FOIL here. It could be 1 times 20. It could be 2 times 10. It could be 4 times 5. I'm about to write 3 just because it was the next one in line. Could be one of these. So what we can do is we can use this process to help us find more dedicated numbers. Instead of going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, yada yada until we find it, knowing that 7, 8, 9 don't even have anything to do with this. Like 7 doesn't go into 60, 8 doesn't go into 60, 9 doesn't go into 60. We can take these numbers and we can multiply one of these numbers. And that gives us potential factors. So if I take this 3, for instance, and I multiply 20, I know that's going to be a factor. 3 times 10, 3 times 5. All of these are numbers that go into 60 for sure. We could then use that number. So let's take 15, for example. I take my calculator, I take 60 divided by 15. I find that its factor partner is 4. And if I make this a negative, that gives me negative 11. That's not what we need for this one, so we know that's not it. If you take 1 times, oh, there it is, 1 times 10, 3 times 2. There is our factors that we end up needing. So let's practice on one that's not as simple as this one. 60, we could probably have made the whole list and gone with it. This one. 5 times negative 56 is 280, and in this case, negative. So I'm going to need two factors that multiply, but we're going to end up subtracting to negative 27. Now if we make our list, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, we'd have to, we check each one of them, 280, 140. I don't think 3 goes into 280. Yep, doesn't. 4 goes in 70. We could keep going to find out that it's going to take us 8 tries because this is the factor that we want right here. So what I want to talk about in this video is using kind of a quicker method. 1 times 5 is our only way to get this. And then for 56, I know there's 1 times 56. There's 2 times 28. 3 doesn't go in. 4 I don't think works either. Oh, it does. 4 and 14. And I know that there's 7 and 8. So what we can do is we can use these numbers and we can kind of find factors that may work. So we skip around in a more dedicated way. So I can take 5 times 1. So we know 5 goes into 280. And its teammate is 56. That doesn't help us combine to 27. So maybe I take 5 times 2, so I have 10. That gives us 28. Ooh, not quite it. 5 times 4, so we have 20. 20 goes into 180 14 times. Not quite. 5 times 7 gives us 35. We see that 35 goes in 8 times. Ding, 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 ding. We have found our factor pair. So instead of having to try 8 different ones, we can get there quicker using this. If it's a little bit larger, let's say 7 times 16 gives us 112. We have 1 times 7. And then over here I have 1 and 16, I have 2 and 8, and I have 4 and 4. So we can take one of these numbers, 1 or the 7. Let's take the 7. We can multiply each one of these numbers to see what our factors could be. 7 times 16 gives us 112. We know 1 and 112 isn't going to work. So we're probably going to avoid that one. So maybe we take 7 times 2. 7 times 2 gives us 14. 14 and 8. So I want to double check. Yep, that doesn't work. So maybe, oops, I don't want to erase that one. Maybe 7 times 8 gives us 56 and 2. There's the one we need. So we can try 7 times each one of these numbers, and we know that we're finding factors that are getting us closer and closer. Again, 7 times 132. 924. In this case, negative. So I need 2 numbers that multiply to 132, but will combine to negative 65. I know we have 1 and 7. 132, all I can think of is 11 and 12. So hopefully one of those works. And if we take 7 times 11 gives us 77. 1 times 12 gives us 12. And there's our factoring pair. If we did our list, it would have taken us at least 12 tries to find it. But coming over here, at least we find one factor that we know helped us find it faster. Let's skip that one. 8 times 63. So we have negative 504. 8 is no longer a prime number, so we have a few more options. We have 1 times 8. It could also be 2 times 4. 63, all of our different options. We have 7 times 9. We have 1 and 63. We have 3 and 21. And so we can kind of guess and check in a more organized fashion. So maybe we take 8 times 7. That's 56. 1 times 9 gives us 9. That's not it. 8 times 9, that's 72. 1 times 7, that's 7. That's not it. Maybe 8 times 1, that's 8 and 63. That's not it. 8 times 63 is not going to be it, so I'm not even going to try that one. 8 times 3 is 24. 1 times 21 is 21, so that's not it. So I don't think it's any of the 1 times 8, so I don't think that's what I need. 2 times 4, so we got 2 times 3, that's 6. 4 times 21, that's 84. That's not it. But maybe it's 2 times 21, that's 42. 4 times 3, that's 12. Oh, we're getting closer, though. 2 times 7, 14. 4 times 9, 36. Not quite it. So maybe 2 times 9 is 18. 4 times 7 is 28. There it is. So it took us 1, 2, 3, 4, 5, 6, 7 tries. If we did our list, that would have taken us 18 tries. So it's a little bit more direct in finding our factors. One last one. 6 times 40, so we have 240. Again, we can make our whole list. Let's see if our new technique can help us out. So we know that we have 1 times 6 or 2 times 3. For 40, I can think of 1 times 40, 2 times 20, 4 times 10, 5 times 8. 6 doesn't work, 7 doesn't work, so we're back to 8. So here's our whole list. Now we're going to kind of run through our factoring options. I'm going to start with a 6, because 1's usually kind of, nobody really needs it. 6 times 40, it's 240. 1 times 1 is 1, so that's definitely not it. 6 times 1, 1 times 40, that's definitely not it. 6 times 2 is 12. 1 times 20 is 20. It's close. That's not it. 6 times 4 is 24. 1 times 10 is 10. Getting closer. 6 times 5 is 30. And 8. So that's not it either. So then maybe 6 times 8, that's 48. So I don't think that's it. 6 times, that's 60, 120. So I don't think it's 1 and 6. So now we're going to try 2 and 3. So 2 times 1 is 2. 3 is 120. So that's definitely not it. 2 times 4 is 8. 3 times 10 is 30. So that's not it. 2 times 5 is 10. 3 times 8 is 24. That's not it. So 2 times 8, 16. 3 times 5, 15. There it is. So what we're doing in this process, just to be 100% clear, is I'm going to take the 2 and I multiply one of these numbers. So if I multiply the 2, the 3 multiplies the 20. If I take the 2 and I multiply the 4, the 3 multiplies the 10. 2 times the 5, 3 times the 8. If I don't find my factors there, I can switch it and I can say, all right, maybe 2 times the 10, which means that 3 times the 4. 2 times the 8, 3 times the 5. And we can switch it. If we made our list, this would have taken us at least 15 tries to get to it. But in this one, we can kind of gauge it as we go. You can think about, as you go, kind of your number size. All right, so if we did 6, we know that it has to be 31, so we want to get numbers near 30 or less than 30 in this case, because we're adding to it. And it helps us narrow down the list so we don't have to try as many. Do I have any last ones that I want to try? Let's go back to this one. All right, so you have negative 420. One thing that can help us with our list is knowing, do we have to add or subtract? Do they need to be positive? Do they have to be negative? So because it's a negative 420, so a negative right here and a negative right there, so we know we're going to have to subtract. So I'm going to need a number that's bigger than 23 and then a number that's smaller than 23. So my options 1 and 10, 2 and 5. Over here I have 1 and 42, 2 and 21, 3 and 14, 4 doesn't work, 5 doesn't work, and then 6 and 7. So in order for this to work, I need one number that's going to be bigger than 23 and one number that's smaller than 23 that when they subtract become 23. So 10 times 42 is way too large. 10 times 1 is 10 and 42. So I have 10 and 42. Doesn't get us there. So this pathway, 1 and 10 and 1 and 42, doesn't work. So maybe it's 10 and 2. That's 20. The other one's 21. Not a big enough gap. 10 times 3, 30. 1 times 14. Getting closer. 10 times 6. 1 times 7. So that's not it either. We could go back through 10 times 7. So that's 70 and 6. That doesn't work. 10 times 14, way too large. 10 times 21, way too large. 10 times 42, way too large. So we've eliminated this as a possibility. Only 5 tries in. 2 and 5. Again, I'm trying to think of ways that I can get a number bigger than 30, but it's not abnormally large. So I'm going to pick the 5. 5 times 6 gives me 30. 2 times 7 gives me 14. It's not bad, we're getting there. So maybe 5 times 7, 35. 2 times 6 is 12. And there's our two numbers. 1, 2, 3, 4, 5, 6, 7 tries instead of 12. Again, not the most direct method that we have here. If, again, you struggle finding those factors, make your list. 1, 2, 3, 4, 5, 6, 7. There will be numbers that you get to skip as you go. But this technique helps us narrow down which numbers are actually available. And you might get lucky if you pick the right number. Like if you did 5 times 7, you would have gotten 35 on a faster trial, or 2 times 7. Just another way to help us find our factors.